So the first thing I want to do today is let's go to page 34 and example 3.9. Example 3.9, and we have done part A, but we haven't done part B yet. So, and in part A, we determine the equivalent force couple system. We have four balls on the. We have four balls on the. We have four balls pushing towards the ship, right? We have four forces pushing towards the ship, and we want to determine the force couple system about O. So, because let's say O is the center of gravity or center of mass here. So we have done part A before, and we changed the single force from both 1 into a force couple system on point O, and then for ship 2, and we changed the force from a single force from ship 2 to a force couple system at point O, and so on. Now, and the question of point B asked that in point B, we need to determine the point on the hull where a single more powerful tugboat should push to produce the same effect as original four tugboats. So the thing is, for a ship, it can produce, it can push a force onto the big ocean liner, but it cannot provide a couple. It can only give a force. It cannot give a moment. So let's say we have a single tugboat. We have a single ship here that it produces the same force as these four ships. Now, in part A, we say for point O that we have a force couple system. We have a force and we have a couple at point, and then we put the force here, right? And then let's say we change it to somewhere here or somewhere here, the force will be the same, but of course the couple part will be different. Okay, if we put the force here, say O prime, then the force and couple will be different. And would there be a point? Is there a point that we have a force here and couple part is equal to 0? Is there somewhere along the ship that we put the force here that we do not have the couple? Okay. Let me mark it here. Force is R, and the couple part. For those who have just come, we are on page 34. Okay, is that we want to find, and of course at the moment we don't know what x is. We don't know what is x. We need to determine x, and if there is one point that we have the couple equal to 0. I think at first that I hope you agree with me that this point is here. There is somewhere at point A that couple is equal to 0, but then we need to find this point. Okay. Now, so for this points that so now that let's say this point exists. Let's say this point exists, and we imagine this force. We imagine this force at somewhere is moved to point O. right? And we know that this is R. We know that this is R, and we know the couple about the force couple system about point O, right? This MO is equal to how much? And 310.7 kilonewton meter, right? And we are imagining that we have a force couple system with force and zero couple moving from point A to point O. And of course, the result at point O that we have already known, right? We have already known the result at point O, but we don't know the result at. We know the result at point A, but we don't know where A is. We don't know where is A. Okay? Now, therefore, that so for this so we say we write like this, and for couple system at O is the force part is easy. Then the force is equal to what? 9.04 I minus 9.79 J kilonewton. This is easy. And this is the force part. We imagine the force moving from A to O. Now the force part is, it does not change. It is 9.04 I minus 9.79 J kilonewton. And how about the couple part? The couple is equal to, let's say this is R. The couple part is MO is equal to R cross the big R, and what is R is equal to OA is equal to XI plus 21J meter. Now we move the force couple system from A to O. Of course, we know everything about the force couple system at O, but we don't know where A is. We don't know where is A, so we have the moment arm is OA, and we know the results here, right? Let me write it down here. You know the force couple system O is from part A. We know the force is this and the couple is this. And we consider page 34. Okay. 34. So here that we know this is R, right? And we know this is R, and we know the force is this one, and the couple. We are thinking from moving from A to O. So this is the moment arm, and this is the couple, and of course from here you will know how to And so we have I, J, K, and X 21 and 0, and this is 9.04 minus 9.7900, and is equal to minus 300.7 K. So X is equal to 12.3 meters. This is, of course, this is the small r, and this is the big R.